Hey Justin, what's going on in here? I see you got the machine on.
Yeah, actually, it's funny that you're here because this is an unscripted, unplanned hot seat. And I got the president and COO, Mr. Todd Roundtree here. The cameras are set up, and we're going to go over some FAQs on the Austin American Technology Jet Inline Series. So we're standing here in front of our demo unit. This is our ExtremeJet. This is Generation 1. This thing has been cut up and beat up, but it's 100% in operational order. We use it daily for demonstrations, both in person and virtually. So Todd, let's start out with a question that we've been hearing a lot about, and it's about this 4.0 CFX industry standard. How does that apply to the inlines and really cleaning in general?
Well, it's interesting you say that. I'm surprised you even know anything about CFX.
I don't actually. I made it up.
Okay. So actually, the interesting portion is that I do know a little bit about 4.0 CFX and what is how it relates to cleaning.
Okay.
And basically, as of right now, there has been no standard developed for a cleaning machine. So they're working on everything else down line, but nothing when it actually gets to the cleaning machine. Now, when it does come to us, it's basically just going to be a protocol that allows the machines to talk to each other and kind of have some data logging and some real-time tracking and things like that. But it just hasn't reached the cleaners yet.
Okay, I'm sure that's a very good answer. Now, moving on, one of the main other things that we hear is always about decibels and noise pollution and everything. And when you're working in an assembly floor, we know how loud those things can get. So, a lot of people like to say around that 80, 85 decibels. Where do we operate with the ExtremeJet and the other inlines that we have on the assembly line?
Well, so the first and foremost, the OSHA regulation is actually anything that's above 85 dB requires ear protection. So we always make sure that our machines come in under 85 dB so we don't have to meet that OSHA requirement. Now, some of the machines will be a little bit quieter than others depending on how they're built, things like that. This machine actually runs at about 79 dB when it's completely wide open. Some of the others that we build can actually go as high as about 84 dB, but if you turn the pumps down a little bit or turn the blower down a little bit, it actually, just by going down 5% on your blower, will actually reduce it almost 5 dBs.
Oh, hang on to that because we're going to go back into that question a little bit more. So, and actually, let's talk a little bit about the pumps. Now, I know the old way was kind of just put the biggest horsepower, the most horsepower, just like we drive our cars, we wanted the big horsepower. Now we're going more into electric motor, less horsepower, sometimes better. How do we compare to the old way of using those high horsepower pumps?
So that's a good point. So the old way was always put in the biggest horsepower pump you could put in, and then you put a bunch of flooding nozzles in your cleaner, and then you had to create as much pressure as you could up here in the manifold in order to get that pressure down on the board surface. Well, AAT, we tend to rethink things, redesign, and basically Steve Stach, when he came up with our coherent jets, we actually use really high flow manifolds, and we use lower pressure pumps because the pressure we actually generate in our manifold is the same pressure we see on our board surface, up to 7 inches away from those manifolds. So we don't need that extra power. In fact, actually, if we were to put a really large horsepower pump on our machine, we would actually denigrate the spray pattern that we have. We'd over-pressurize it. So in other words, rather than getting a nice tight stream down on the board surface, we'd end up with kind of something that fanned out. So therefore, we don't need all that.
Okay.
It's the new way.
Well, I think not only the new way helps with the efficiency of the product, but we're also talking about the cost of the product too. When you're running those high horsepower engines, and we just answered a question about decibels, I'm sure that means more noise, more power consumption, more cost. And
Absolutely.
Going on to the drying section, I'll move down a little bit because I know you're going to want to come with me here a little. Do we use two separate blowers or one blower when we operate in the drying section?
So we only use one blower in our dryer section, and I'll tell you why. We looked at the old way that they did things, and the old way was always put an air knife in and then try to give a whole bunch of separation, maybe some heaters in there, and then another air knife. Well, air knives are not real great at removing moisture. They're real good for just kind of pushing some moisture off, but they don't really remove it. So once again, AAT, we decided we were going to rethink that, and we came up with our jet impingement dryers. So what happens is we have one blower that we can actually run those jet impingement dryers, and we get more power, once again, on the board surface that we don't require a heater. In fact, actually, this is something that's even maybe unique to us, is that we tend to dry in 36 inches, where the old way of doing it was dry in a 10-foot section.
So you can tell that Todd has obviously handled some of these FAQs on the inline for a while, because the very next question I was going to ask is why we don't have a heater in the drying section.
Well, and once again, it's it goes back to what I just said. So we really don't need it because we can actually remove the water from the board surface. We can physically remove it, actually push it away. We're not trying to evaporate it. But number two, our turbine does, in all honesty, our turbine does create some heat. So therefore, we do have some heat in our dry section. It's not something that you can set. It's not something that we really control. But we do run somewhere between 50 and 60 C in our dry section just from the friction of the turbine.
Got it. All right. Now, we're going to get into the real hot seat questions. And you can talk about the machine. You can spit that right off the top of your head. But now I'm going to hit you with the tough ones.
All right.
Let's start with what makes AAT's inlines unique from our competition?
There's several things. For one, we use different cleaning technology than most other manufacturers. Not all. Some of them have begun to come around to our way of thinking, but we do use our progressive energy jet dynamics. That would be one way that we set ourselves apart. Number two would be in footprint. We do have the smallest machines on the market, and that really is kind of number three, or relates to number three, is our drying. Nobody else dries like ours does. In fact, actually, it is a patented dryer, which could be a reason why nobody dries like us right now. And then the number four, the other thing that I would state too, is that we really focus on energy consumption and closed loop technology and things like that. So all of our machines come equipped closed loop when they're built. And then number two, we put VFDs, variable frequency drives, on all of our pumps and motors to actually use less energy.
Got it. So, all right. So Todd has obviously gone through these questions as I shared already, and I've kind of teed him up. I'm being a nice guy today with the hot seat. So the next question is, what is the cost of ownership for each equipment?
Well, once again, that's going to vary immensely between different machines, but we do have some information that we share with our customers about our chemistry consumption data, which takes into account water evaporation. It takes into account the chemistry that we actually carry over from one to the other, what goes out the stack, how much electricity we use, how many volts, things like that. So we do have all that stuff available.
Yeah, and we'll make sure that if you do inquire about that and you have that specific question, we'll send you all of the data that we have on that. And one thing that we really want to stress on is we've already built in all the components to make it as highly efficient as possible. So that way, when it comes to just the pure operating costs, like you mentioned about water consumption, chemistry consumption, electricity consumption, we've already dialed that down as much as possible for you by using the lower horsepower pumps, by using the VFDs?
Yep,
the VFDs to help overcompensate for the cost that you would normally have to spend when doing it the old way. Going on to the next question, what makes the equipment easy to use and quick to program?
Really easy to use would just be, a very large usable interface. And, as far as programming it, there's really not much to programming, especially in an inline planer. You just want to make sure you set your temperatures, you set your belt speed, your resistivity, stuff like that. And then basically just turn it on and let it go. So
you hired me only 5, 6, 7 months ago, and you had me on this thing first day. First day I had all the buttons all figured out. It was like running a car wash. It was actually pretty cool. All right, going on to the next question. What are the elements of the equipment for a quick changeover?
And that really kind of quick changeover is kind of maybe a loaded question, especially when it comes to an inline cleaner. So I'm going to assume by that question, what they mean is if you wanted to change the recipe, so to speak, that you're running. So it's very easy to adjust your belt speed. You can do that through the HMI. It's very easy to adjust your pressures. We actually, since we do use VFDs, we are able to adjust the pressure the board sees actually from our HMI. You don't have to go around the back of the machine and turn valves and things like that. You can do it all up front. But the hardest part would be to change your temperature. It's really easy to raise the temperature in one of these, very difficult to lower the temperature in one of these. Got to let it just sit for a really long time.
And I assume by sit, you mean almost turn it off, because we already know that the power alone is going to be generating some heat.
That's correct.
That's absolutely. Correct. So, all right, next question we have here. What are the inventory management software capabilities?
We get that question a lot, but you have to understand a lot of times when people ask these questions, they're thinking about some other equipment. So inventory management, there's really nothing in this machine that's going to consume any of your inventory. No parts, no components, no things like that. So it's really kind of a mute question. These really don't track anything or have any software that talks about that.
And would you say that's an Austin American thing, or is that more just industry across the board?
Just cleaning industry wide.
Yeah. So that question really relies more like towards like
pick and place
machine.
machine. Yeah, something like that.
All right, makes sense. All right. And what is the software stability?
That's actually a great question as well. And we do get that quite a bit. There's basically two schools of thought in software. And one would be, and maybe kind of some of the more common, but anyhow, would be a Windows-based system. So Windows-based systems are very inexpensive to buy a little PC, and they're pretty easy to program. But the problem with them is that you constantly have to do updates, and they're very susceptible to viruses. So therefore, we actually opt to use PLCs instead. They're industrial based. They're still very easily programmed. They are still inexpensive as well, but they're a little more robust. They're built for an industry environment, and they're built to withstand.
Got it. All right, and I got one more question for you, Todd, and I already kind of know the answer, but I'm going to tee it up for you. What differentiates equipment reliability from other suppliers? And I really know that a lot of the times this question comes up, they're talking about why is this not stainless steel, or can we get it in stainless steel, or why should we not have stainless steel? So that's a lot rolled into one, but let's go ahead and talk about the reliability of Austin American's jet inline cleaners.
Yeah, so reliability, we've been building these since 2000. Several of the ones that we actually built in 2000 are still being used today, with no leaks, I might add. And the reason why I bring that up is that's probably one of the biggest complaints of an actual plastic machine or a polypro machine. And if the welding is not done correctly, then yes, you can get leaks. But if it's done correctly, as we do it here, then we don't really have any issues of leaks. Have we ever had leaks? Absolutely, but they're easily repaired. So, on longevity, I would say as far as the body, these bodies are actually made to last for life. They're much less expensive than stainless steel, about half the cost of stainless steel, considerably less weight. So as long as with proper care, these things will last pretty much, as long as you want them to. And then on the other side, so all of our components, pumps, motors, things like that, we've talked about VFDs once before. I'll mention it again. The VFDs are going to protect your pumps and motors like nothing else because they do soft starts and soft shutdowns. So therefore, it's not an immediate pump to make it actually turn on. We start it real slow and we rev up from there. And then when we shut down, we do the same thing. We slowly shut them down.
Got it. When we're talking about slow, we're not talking about minutes or hours. We're just talking about a gradual shut off, gradual turn on. And that's really just about how you protect the equipment that operates the machine. So those are all the questions I have for you today, Todd. I know I kind of got you just walking through the demo room, but every once in a while I like to stage some things. I get bored sitting back here in the demo room, so I might as well turn the cameras on. But nice. Todd, I want to thank you for your time. Anything else you think we need to add?
I don't think so.
All right. Have a good day, everybody.
Thanks.